paragraph, question number 2 on ladder friction. Let's see what is given here. A ladder of weight 400 Newton and length 10 meter is supported on smooth wall with its lower end 4 meter away from the wall. The coefficient of friction between floor and the ladder is 0.3. Full stop. Find frictional force at the floor. Whatever things are given in the question, we would be writing that in the form of a data. Here we have wall and floor. Over that a ladder is resting. It is given a ladder of weight 400 Newton, W is 400, will be acting at exactly half of its length. So here we have W. Next, and length 10 meter. The entire length of the ladder is 10. So I have divided it into 5 meters on either side. Next, with its lower end 4 meter away from the wall. This lower end of the ladder is 4 meter away from the wall. Then the coefficient of friction between the floor and the ladder is 0.3. So they have given us that there is friction between the floor and the ladder, and the value of coefficient of friction is 0.3. The question is, find the frictional force at the floor. So here we have to calculate the value of F suffix F, friction force at the floor. Since about the wall they have specified nothing, they have not given the coefficient of friction for the wall, we can say that the wall is smooth, and for that mu value will be equal to 0, and therefore frictional force offered by the wall, that will also be 0. Now, since we can see in this problem the ladder is resting against a wall, so there would be reaction offered by the wall, which is horizontal reaction. Then after that, similarly for the floor, there would be reaction offered in the upward direction, which is RF. Ladder will try to slip because of its weight towards the left, but friction force would try to, so I can show the motion here. Motion of the ladder is towards left, and opposite to motion there will be friction force. So friction force would try to keep the ladder in its original position, that is F suffix F is equal to mu F into RF. Now this is the condition which we have in front of us. First, what we would do, we would try to get the inclination of this ladder. I'll say that this angle is theta, inclination with respect to the floor, and this can be calculated as, here I have hypotenuse as 10 and this adjacent side is 4, so I can say that since cos theta is equal to adjacent upon hypotenuse, that is 4 divided by 10, therefore theta will be cos inverse of 0.4. so my answer of theta, here I have this as 66.42 degree, and here I have to calculate F suffix F. That's my question. So with these much data available, let us try to solve this question. I'll say that considering the ladder is just on the point of slipping, it is just on the point of slipping means it is in limiting equilibrium condition. So I'll say that summation of Fx is equal to 0, where my rightward forces would be positive and leftward forces would be negative. So therefore, here I have reaction offered by wall as positive, friction force offered by the floor negative. So I'll say that therefore friction force offered by the floor, which is F suffix F, is equal to Rw. I will keep this as my equation number 1. Now I would be taking the moments of all forces about point A, that is at floor. I'll say that taking moments of all forces about point A, that is summation of moments about all forces at point A is equal to 0, where my clockwise moments are positive and anti-clockwise moments are negative. So I'll say that therefore I need to get the distances also. Here I have, since this angle is theta and the adjacent side is 4, I need to find out what is this side. So I can say that this is the opposite side. So here this would be 10 cos theta and this would be equal to 5 cos theta. Tan, it would be opposite, so it would be 10 sine, not 10 cos. It would be 10 sine of theta, and here also this would be 5 sine of theta. So just making a correction here. Now I would be taking the moments at point A. I'll say that first, starting with Rw, it is in clockwise direction, so it is plus Rw into 10 sine theta. Theta is 66.42 degree. We have just calculated it in the data. Then W is anti-clockwise, so minus W into 5 sine theta, that is 5 sine 66.42 degree. And as we see here, the moment of RF and FF would be 0 because they are passing through the same point. So I have this much is equal to 0. Therefore, I will have Rw into this value of 10 sine 66.42 degree, that comes out to be 9.165. And if I shift these terms on other side, W is given to me as 400 Newton. So 400 into 5 sine 66.42 degree. Therefore, I have 9.165 Rw will be equal to 800.06, this right hand side value, and therefore Rw will be equal to 800.06 divided by 9.165, and Rw comes out to be 87.29 Newton. Now I would be putting this value in equation number 1. So I'll say that put Rw in equation number 1. So hence I would be getting the frictional force offered by the floor as 87.29 Newton. That is my answer. And if I look into this question, they were telling us to calculate the friction force offered by the floor, and that answer which I have got is 87.29 Newton. We have calculated the friction force which would try to keep the ladder in contact with the floor and the wall, and with this we complete the question.